Conservation of momentum. So according to the law of conservation of momentum, the total momentum in a system remains the same if no external forces act on the system. And so there will be two types of collisions that occur. Law of conservation of momentum. The first one that will occur is an elastic collision. An elastic collision is a collision in which objects collide and bounce apart with no energy loss. So in an elastic collision, because momentum is conserved, the mv, the mass times the velocity, before a collision for each of the two objects must equal the mv after a collision for the two objects. And you write it like this. The mass of object 1 times the velocity of object 1 plus the mass of object 2 times the velocity of object 2 equals mass of object 1 times velocity 1 equals m1 v1 final plus m2 v2. The subscripts 1 and 2 refer to the objects respectively. A second type of collision is an inelastic, in which objects collide and some mechanical energy is transformed into heat. Now, a common kind of elastic collision is one in which colliding objects stick together, or they start out stuck and then they separate. However, in an inelastic collision, the objects need not remain stuck together, but instead they somehow end up maybe deformed in some way. Now, because momentum is also conserved in an inelastic collision, the mv before the collision for each of the two objects must equal the mv afterwards. However, it changes the formula a little bit. When objects are stuck together after the collision, assuming that the mass doesn't change, this equation becomes like this. m1 v1 initial plus m2 v2 initial is equal to m1 plus m2 times v final, where v final is the final velocity of the two objects together. Now, let's look at an example. Two brothers have a combined mass of 200 kilograms, and they're zooming along in a 100 kilogram amusement park bumper car at 10 meters per second. They bump another car which is sitting still. Now, if that car had a mass of 25 kilograms, after the collision, the twins continue ahead with a speed of 4.12 meters per second. How fast was that car that was sitting still bumped across the floor? So here's what we do. Notice that you must add the mass of the bumper cars to the mass of the riders. So here's what we're given. Mass 1, mass 2, volume 1 initial, volume 2 initial, v1 final, because these are the things that we are given. So we know that the two brothers have a combined mass of 200 kilograms. They're zooming along in a 100 kilogram car. So that's 300 kilograms total. Now, they bump into a car which is sitting still, which has a mass of 25 kilograms, the person sitting in it. So that's a total mass of 125 kilograms. The boy's car is moving at 10 meters per second. The car that's sitting still isn't moving. After they collide, they're moving on with a speed of 4.12 meters per second. So what are we looking for? We're looking for V2 final. So we go and we look at what equations we have. Notice we're going to use the first type of equation. This one is an elastic equation. What's the original equation? The original equation is m1 v1 initial plus m2 v2 initial equals m1 v1 final plus m2 v2 final. So if we rearrange to solve for v2 final, we will have v2 final is equal to m1 v1 initial plus m2 v2 initial minus, we're taking this to the other side, m1 v1 final divided by m2. Now that we have it rearranged, we just plug in our numbers. 300 kilograms for our mass 1 times our velocity was 10 meters per second, okay, plus our mass 2 was 125, minus the 300 kilograms, because that was mass 1, times 4.12 divided by 125 kilograms. We go through, we do the math, we will come up with 14.1 meters per second. Okay?